Okay, lesson 2. It's called GCF and LCM. So what do those letters stand for? Have you seen those letters before? Greatest common factor. Greatest common factor. And yeah, lowest or least, I don't know what I usually say, lowest common multiple. Okay, so let's quickly talk about what does a multiple mean and what does a factor mean. So I'll go back to that in a second, but let's take the number 20. What are multiples of 20? 40. Well, I'll start with 20. 20 is a multiple. 40, 60. So, okay, you get that point that they're, obviously we'll keep going. So that means a multiple, which is itself, or it would have to be bigger yet, right? Then if I say the opposite way, what is a factor of 20? So now think kind of opposite of what we just did. So what could I divide 20 by? 1, 2, 4, 5, what else? 10, 20. Okay, I'm going to take a very simple example here. So my example is just between a 4 and a 6. What kind of factor would they each have, and what would it be as the biggest? What could I divide them both by? 2. That's the greatest common factor between both of them. And the lowest common multiple, so think of a number that I can divide by 4 and by 6. And I'm trying to, when I pick that number, I'm trying to pick the smallest one I possibly could. 24 works, but it's not the smallest one. 12, yeah. So yes, 24 is a multiple, a common multiple, but it's not the lowest one. Okay, so that's how this is working. Okay, then we are going to need to know what a prime number is. Have you heard that number before somewhere? Prime number? What is it?
A number that only has 1 and itself as factors.
A number that can only ever be divided by 1 and itself, and that's it. So obviously 20 is not prime because I could divide it by a bunch of things, right? Okay, so the very, very first prime number is 2. Okay, 1 is actually not a prime number. Okay, so 2 is the first one. What about 3? Would you think a yes or no? Yeah. It's just 3 times 1. There's no other thing. Okay. Are you okay if I tell you this? There's 2 is the only even prime number. That's it. Right? Because once you hit 4, you can divide it 1 and 4 or 2 and 2. 6, 1, 6, 2, 3. So we're done even numbers. So 5. Yeah or no? Yep. The next odd is 7. Can you divide 7 by anything other than itself in 1? What about 9?
No.
No, because it has 3 and 3 now. So that doesn't work. 11?
Yes.
11 times 1 is it? 13.
Yes.
What about 15?
No.
No, because you got 5 and 3. Okay, I could go on. Obviously, 17, 19, 23. You got a bunch, but. Okay. Here we go. Find the LCM and GCF for 35 and 49. Okay, so we're going to start with 35. I'm going to start with the lowest prime number. Is this divisible by 2?
No.
No. Would that be divisible by 3?
No.
No. Do you guys know how to tell if something's divisible by 3 by looking at it? What does 3 plus 5 add up to? 8. Is 8 divisible by 3?
No.
No. So then 35 is not divisible by 3. Would I be able to divide it by the next prime number, 5? Yes. 5 times 7. We're done. Because you finish when everything you have is prime. Okay, so 49. What is the first prime number I can divide by? 2, 3, 5, 7, 11. Do you have any in that list?
7.
7. 7 times 7. Okay, now we're going to circle anything that's common in each. So each of them, can you agree that they each have a 7?
Yes.
So, therefore, the greatest common factor is 7. Okay, and this is how I'm going to find the lowest common multiple. Did anything overlap? Yeah, there was a 7. So let's just pretend that I covered the overlap numbers up. What do I have else? I have a 5 and a 7. And then I did this in my calculator. That's fine. And I get 245. So 245 is the first number I can find that should be divisible by 35. Let's check it out. Yep. And 245 should also be divisible by 49. Okay, let's try another one. 98. So I'm going to start with the lowest that I can. So I'm going to start with 2. 2 times, and I would do this in my calculator probably, 98 divided by 2, 49. And then I have to keep going because 49 isn't prime. So what prime number would I divide that by? 7. So I'm going to conclude it as a whole now. This would be a 2 times a 7 times a 7. 2 times 7 times 7 makes 98. $126, I can tell that it's divisible by 2 because it's even, right? It ends with a 6. Okay, so 126 divided by 2 is 63. Can you divide 63 by 2? No, it's not even. Do you think it's divisible by 3? Yes, because 6 plus 3 is 9. And so 3 times would be 21. Okay, what do you want to do with the 21? What can I divide that by? 3? 3 times 7? And I'm done, because I've reached all prime numbers at the bottom. So 2 times 3 times 3 times 7. Okay, show me what I can circle in both. So they both have a 2. And they both would have a 7. Right? Done. That's it. Do you understand that you can only circle one 7 to match with that one 7, right? So they're both divisible by 14. That's the largest number I'd be able to divide them both by. Okay? If you don't trust it, let's just check it out. Is 98 divisible by 14? 126, is it divisible by 14? Okay, so we had 14 was the overlap part. And then what else do I see that I didn't circle? So there was another 7, a 3, and a 3 that didn't get circled. The leftovers. Okay, is that okay? 888, that's what we're getting. Okay, number 3. Okay, always start with 2 and work your way up. So is it divisible by 2? 2 times 60. Now I look at the 60. Also 2. Okay, stick with the 2 until you can say that's no longer a 2. So 2 times 30. Guess what? Another 2. 30 is divisible by 2. Anybody know that one offhand? 15. Okay, 15. I'm done with 2 now. So I move up to a 3. Is it divisible by 3? 3 times 5. And now look at us. We've reached all prime numbers. All those numbers are now prime. So I'm going to write this all 2 times 2 times 2 times 3 times 5. That would be 120 altogether, right? Ooh, this is a big one. We might have a long tree here. Okay. 2. 308. That's going to have to be a 2 again because that's even. 154. 2 again, it's even. Keep dividing by 2, 77. Okay, I'm done with 2's. So 3, nope, 4, or it's not even, I'm not even looking at 4. 5, nope, 7. 7, 11, yeah. And 11 is prime. So that means you're done. So what would they all have in common as factors? I can do a 2. I can do a second 2. I can do a third 2. That's it, right? So that means the largest number I could divide them both by is 8. They're both divisible by 8. Okay, so now I say, well, all those factors in common was 8 times all the leftovers that I have not circled. So I have a 3, a 5, a 7, and 11. So this is going to be a pretty large number. So that's the first number I can find that I'd be able to divide by 120 and by 616. Does that make sense? That's the first number that you'll ever find that you can do both of that with. Okay. Are you okay if I skip the next example? Is 3 of those? I'm going to do one more, but I'm going to do it harder. Is that okay? If I skip to the next level? Because this is 3 numbers now. Okay. $60, $84, and $44. Okay, I'm gonna let you go on your own to get your whole tree. Okay, see if you can get me your trees. Okay, let's see if we did this all the same. So 2 and 30, 2 and 15, 3 and 5. Are we all matching? Absolutely. Okay. 2, 42, 2 and 21, 3, 7. Okay, 42, 222, 211, done? Okay, so GCF, we are going to do the exact same. Everything has a what? A 2, so circle, circle, circle. Everything else still has another 2. That is it, right? They have to all have something, and that's it. So 4 is the largest number I can pick. I can divide 60 by 4, I can divide 84 by 4, and 44 by 4. That's the biggest number that I could possibly do. Okay, so we always did this. The first thing was, what do they all have in common? So that was 4. Now, this is what changes. Before, I just did all the leftovers. But now I've added another ladder. So, 2 in common. And then the leftovers, which are singles. So that's just adding one ladder to it. So, are there any numbers where just 2 of them have it? Yeah, 3. You know what? I think I'm going to do a box just to make it a little different. I'm going to put a box around that because they don't all have a 3, but 2 of them have a 3. Then, now you can go to what's left over. So 5, a 7, and an 11. Okay, so that just adds one little piece to it. So 4,620 is the first number I can find that I'd be able to divide by all of those. Okay, what do you think? Do you want one more of those? I have 2 more in the paper. Do you want?
Can you do the 4?
What's that? I will come do it with you after. What are we doing? 6 or 7? Or none? What do you want? You tell me. Should we do? I think we should do one more of these. Which one looks? 6? Oh, I didn't even realize I went up to 4 on that one. Ooh. I could challenge you on that. Okay, again, I'm going to give you your own minute here. You can get your own tree. Okay, so the GCF is the question to what is all in common. So you'd have to have it in all 3. So let's see what we can find. I can see a 2. No more 2s in all of them, right? They all have a 3. I can take a 5 from them all. Are we good with just that?
Yeah.
That's what you got? So 30 is the biggest number that will divide into all of them. Okay, so LCM. So you're thinking all 3 in common. We already did that, which came out to be 30. So now we added this rung to the ladder. So do 2 of them have something? I can take a 2 out of that one and that one. So I'm going to put a box. And that's it, right? And then leftovers, I still see a 2 and a 3. You can always look when you're done, right? Because 360, you should be able to divide it by 60, divide it by 120, and by 90. Okay, we're not going to do 7, but what do you think I would do on my LCM at the very end if there's 4? 4 common, then 3 in common, then 2, and then singles, right? You're just adding 1 to that. If anybody wants to try that on your own, I will put the answer up if you want. Otherwise, you're jumping into your booklets to start working.